All right, hi guys, and welcome to the last class of this year that we're going to have together. On popular request, and it was also my intention to do so, by the way, we are doing this sort of session, which is not a particular past paper that we're looking at today. Rather, it's going to be very, very general in terms of what it goes over. So it's basically general tips that we're doing related to MCQs. And even before that, I would like you guys to do me a favor, which is that whatever you remember came in your physics P2, first I just want you guys to write it down on chat. So anything you remember, because I did this exactly for O levels, and what I predicted to come in the paper was according to what I knew was already assessed in the P2. So pretty much like AS O level P2 happens first, and then O level P1 happens. So I did the same thing there, and believe me, the paper prediction that I gave them was very, very accurate. So I basically gave them a pool of 60 questions, and out of that, uh, like 25 questions were a definite hit in terms of what was supposed to be assessed. No worries, Rania. Just let me know whatever you remember from AS, what the questions were. So that's going to help me a lot in this session. Right, so I'm going to go over some of the key mistakes and what questions can possibly come in today. Anything you remember, like what question came in? I need your feedback on this. Whatever you remember, like from waves, what sort of a question that was, just type it out and send it to me. Yes, from the P2. Mm-hmm. And what else? How about dynamics? Do you remember what exactly came? Was it a graph question on momentum, or was it like a separate type of question? Was relative speeds assessed? Relative speed of approach equals relative speed of separation. Hmm. All right. So whatever you remember, just keep typing. Right. Some things will come to you with time. Actually, what made the O level session very easy for me was this, that I actually got the paper like exactly when the paper actually concluded. Uh, on a group, I got the solved PDF of the paper, and I searched a lot. I searched a lot for the ES paper, but I couldn't find anything of that sort. So if you go on, yeah, please just send me the link. I would be very thankful. All right, just a sec. Let me go get my charger. All right. Uh, Thanks for the link. Let me just open this up really quickly. So first I'll just see what I've written here. So this is just some basic stuff for attempting the paper. I'll be going over this in a while I go through the paper. All right. So yeah, all in all, I'm pretty sure this is an easy paper. Yes, thank you. No, the link was working. I was going through it. So yeah, that helps a lot. Thank you, Rani. Yeah. So first things first, let's get back here. Yeah. So all of you know that you have to attempt 40 MCQs in a time of 1 hour 15 minutes. That's approximately 1.8 minutes per question. Exactly, it's 1.875. But you know that some questions are hard and you might be expected to spend more time over it. Some of these are going to be really very easy. For example, like definitions of potential difference, or just for example, identifying definitions or identifying what certain laws say. Whereas other questions, and you have seen this, and in my opinion, paper one is the most difficult paper in the entire AS, in all of the AS physics papers. It's definitely the most difficult. So some places you would be expected to spend more time. So this is just an average figure, right? Let's talk about a case which is very likely going to happen tomorrow, and it's important to prepare for it in advance mentally, which is that you will have a question which is going to be difficult. In any AS paper, you do have 3 to 4 questions or maybe near some, maybe like 6 to 7 questions, which are going to be slightly harder than the rest of the questions. They are going to be a cut above the rest. In that question, let's say instead of 1.8 minutes, and again, 1.8 minutes as a time is a bit difficult to understand what this really is. So 1.8 times 60, it's like 100 seconds, right? So let's say instead of spending 100 seconds on one of those questions, you spend twice as much that time. You spend like 200 seconds on a question. That's fine, right? Again, a hard question does not mean that you just look at it and say that it's hard and you move on. But I'm saying that you look at that question, you read that question carefully, you write out everything you know regarding that certain topic, and still you do not see a way through. In that case, don't obsess over the question itself. Skip it for the time being, go forward, complete the rest of the paper, and then come back, right? That's what you're supposed to. Once you're pretty sure that you have given it your 100%, you can't see a way through, then don't stress over it. Go forward, do the rest of the questions, and then come back. But otherwise, do attempt the paper in order, right? The first question, second, third, in that order. So the first questions are going to be easy, and then there are going to be the harder questions, which is going to be kinematics and dynamics. And then there, in my opinion, the questions after that are slightly easier, which are deformation and work energy power. Forces is also, it's very subjective. I used to find forces, density and pressure, that chapter difficult. Some people might not. Then you go forward, waves and electricity is difficult. Again, it's a mix of easy as well as difficult questions. And then the last few questions, which are related to particle physics, and particle physics is really easy, right? So just do it in that natural order which the examiner has given. When you do come back to one of those questions and you find that you still cannot you still cannot figure out how to do it, then you use a process of elimination and take a guess. For example, if you guys recall, then in one of the most recent classes, uh, I told you guys this, that for example, in a question which relies on the maximum number of bright fringes in the case of a diffraction grating, how many of those would you get? By the way, that question is definitely not going to come on the paper tomorrow because it just came in your P2s, right? But I'm just saying that as an example, I told you guys that it could never be even because you have some on this side, some on this side, and one central maxima. So it's always going to be an odd number. So you can use some of these to like disqualify some options for sure, right? And if you see such questions, now we are also going to use the same method here, and then you take a guess. Do not leave anything empty, right? Attempt all questions to the best of your ability. All right. So now going back to the idea of the paper and the questions that I am going to predict. So first question is definitely going to be something along this sort, which is basically going to be what it means to be a physical quantity. Or maybe if it's not a physical quantity question, it could be a question which is going to be on SI units. Now, what I mean by this is you guys must have seen questions with me as well, where we have done some questions. And the first question of that MCQ was, what is a physical quantity? So for example, efficiency is not a physical quantity because even though it has a magnitude, it does not have a unit. A physical quantity means it has a magnitude and a unit both. It does not necessarily need to be an SI unit as well. If somebody gives you a temperature of 200 Fahrenheit, that is a physical quantity, right? So it just needs a magnitude, just needs a unit. The first question without fault is going to be this. Or if the examiner is feeling very adventurous, it could also be this. Estimates, right? So with estimates, again, this is something that you guys must have built up with your study of AS along the year. I remember that there are some videos on alt in which I have gone over estimates. Again, yes, with estimates, uh, you can't really predict the type of question which is going to come in. But I would say generally, like if you think about estimates, then things like volume of certain things that is good to revise, because in recent times there have been questions on volume. Yes. Basically things related to the size of the atom, right? This sort of a thing, and then maybe things related to lengths or heights. This is important. Also, whenever you are thinking about, like for example, you're thinking about finding some quantity like kinetic energy or maybe height or something, then always make sure that you are working with SI units, right? Because a lot of students do make mistakes with this. For example, if I'm talking about the height of an average person, let's say the first height figure that comes to mind is 6 feet, but six is in feet. When you convert that to meters, as you should, because all the answers will be given in units of in SI units as well. So you should then be thinking about meters, which is like 1.84 meters, right? So always think in terms of SI units. Similarly, if speed is given to you in kilometers per hour, so remember this conversion, that 36 kilometers per hour is basically equal to 10 meters per second. So if you remember this value pair, then you can always work around with this. For example, if the examiner asks you how much is 100 kilometers per hour, so you can place X there and then you can cross multiply, right? So do keep some of these things in handy. Do go through all the estimates once. Some common ones are like the mass of an apple, mass of a human being, mass of a lorry, mass of a car, that sort of thing. All right. Also make sure that you understand how densities work. So floating, sinking, that sort of thing. That has also come in the past. So just go through estimates once, right? Again, there is no such set pattern of the type of questions that could be assessed in estimates, right? It's very open-ended, which is, again, Rania, why it's harder. So physical quantity estimates. So let me now go back again to your structured questions paper. So there is then going to be a question on homogeneity. So in homogeneity, I think the most complex cases are those where you have unknown powers. But in the grand scheme of things, in the entire AS syllabus, it's not all that difficult. Unknown powers. Then something else which is also definitely going to be assessed tomorrow is basically precision versus accuracy. So that precision versus accuracy, random versus systematic errors, that thing. How you can get rid of these. So remember that random errors you can get rid of by averaging. You cannot get rid of systematic errors by averaging, right? So that's what I'm talking about right now. So that sort of a thing is going to be assessed. All right, sure. Homogeneity with unknown powers. Let's see, I might have a question here. All right, I can't find it right now for some reason, but later I will give you an example of that. But by the way, it's really easy. It's basically going to be a question like this, that, for example, somebody gives you this expression F equals to rho A V to the power N, right? This is the expression, and you have to find this unknown power N. How do you go about doing this? And you're told that F is force, rho is density, A is area, V is velocity. By the way, whoever remembers mass flow rate already knows what this N is. But let's try to find this out. So force is F equals ma, so kg meter per second square. Density is kg per meter cube. Let's do it on a separate slide just to keep this one nice and pretty. Yeah. So this is kg per meter cube, area is meter square, and v is speed, which is meter per second, and this is raised to the power n. Now the thing here that you see is that this is kg per meter cube, this is meter square, and when I expand the brackets, this is mn, and this is s minus n. Now, if I just compare, and I can do this with either of these, I can either look at M or I can look at S, but M is more complex. S is very easy because there's one S term here, there's one S term here. So for these S terms, their powers must also be equal. So minus N equals minus 2, which leads to N equals to 2. This is the unknown power question that I'm talking about. Right? So with unknown power questions, remember that power raised to another power means powers multiplied. So it became mn s minus n, right? Powers didn't add, they multiplied. So this sort of a question, then definitely a question on percentage uncertainties as well. This is like an examiner favorite, it always comes up. In questions related to percentage uncertainties, do make sure that you understand what is going to be the subject of your equation. For example, in an equation that looks like this, maybe the examiner has given you percentage uncertainties for A and percentage uncertainties for S. And you are maybe asked to find the percentage uncertainty in T. So do remember that first you would have to rearrange the equation, right? So this would become T square equals 2S over A. So then that would become T equals to root 2S over A. So what this implies for the uncertainties is that the percentage uncertainty in T, because of the root, is half, because root means power of half the uncertainty in S plus the uncertainty. All right. So do make sure that you are very, very alert, which is why another unofficial sort of piece of advice is this, that do make sure you sleep well going into your exams. Don't pull all-nighters, please. So this is the example of the percentage uncertainties question, some things that come to mind. Then you are going to have in kinematics, you might have like a definition or something, right? Simple units. Then if the examiner is slightly adventurous, again, there is definitely going to be a graph question. But again, in my opinion, because graph question has come in, right? Again, it could come in, maybe it's like a free fall question, but let's keep that for later. There's definitely going to be a usage of equations of motion. Projectile motion is also definitely in. This is 8. Projectile or half projectile. In projectile motion, we have done the most difficult questions in class, which involve graphs. So whenever faced with graphs, another piece of advice is always try to come up with an equation. All right. So projectile, half projectile, like that. With projectile motion, do remember that if you're asked a horizontal distance, you'll also need to work with the horizontal velocities. For example, if you're asked the range of the projectile, which is that horizontal distance, so that would just be the horizontal velocity times the time of the journey. But vertical max height, that because it's a vertical max height, so it also has to be calculated using the vertical component of the velocity, which then becomes zero at the max height. So do make sure that you remember that sort of stuff. Also with projectile motion, remember that the velocity never becomes zero. I'm talking about the resultant velocity at any point because it always has that horizontal component which is consistently there. So projectile motion, the velocity is never zero. Then after projectile motion, let's see a paper so that I know exactly what I'm talking about. And what better paper to look at than the March 24, by the way, which I've solved and uploaded to the channel. Yeah, definitely. Yes. I forgot this totally. So maybe something on vector triangles. Maybe it comes in later in the paper. So vector triangles and I mean, this is really the heart of AS forces and dynamics. The basic resolution of forces, sine, cos, right? So that's that. And then apart from this, kinematics graphs we talked about. This is the definition type of question I was discussing. Do make sure that if you're asked the definition of a term, make sure you know that it's the definition and not something which could factually be correct, but it's not the definition, right? So you can go to the YouTube video for more detail regarding this. This is definitely going to be on there. No questions here. And again, right now you can see that probably at 11, the other topics start to come in, but I am going to give you guys a pool of questions. So like 60 questions. And then you should know all of those at a minimum. Elastic and elastic. There were some good questions in the March 24 series regarding that. Also, there was nothing on conservation of momentum, if I'm correct. I mean, there were momentum questions here and there. Yeah. So one or two questions here. POCOM means principle of conservation of momentum. So remember that if an object rebounds, it means there's a change in direction, and hence you do need to define a sign convention. Force as a definition is the rate of change of momentum. MV is momentum, right? So this, and then mass flow rate questions are also, it's a really high probability that a mass flow rate question comes in. Remember these two equations, or rather, if you have the time, then make sure you actually understand the derivations as well. That way you are not basically relying on your memory. Run your questions, I'll basically do towards the end. I'm just talking about some tips and tricks that come to mind. Questions I'll look at towards the end. All right. So with dynamics, yes, a Newton's second law question. Again, this is not really according to order, but rather this is a more broad sort of a, it's just like the possibility of questions which could come in because Newton's second law was also not assessed at all. Newton's second law, Newton's third law, also not assessed. with Newton's third law, remember this thing, that there are some similarities and there are some differences. The similarities is the magnitude of the force, and the magnitude of the forces are equal. And the similarity is that it's the same type of force. Whereas for the difference is that it's on different bodies, different bodies. So it's acting on different objects and it's opposite in directions. So I'm pretty sure that nobody makes that rookie mistake nowadays, that something, a object resting on a box. So in that case, the weight of the box and the reaction flow exerted by the floor on the box is not in Newton's third law, because they both act on the box, right? For it to be a Newton's third law pair, they must act on different objects. All right. So other than this, what else? Let's see, if I just go through the syllabus, probably we'll come up with some ideas. How could I forget? Terminal velocity. So with terminal velocity, cases of the falling parachutist. And even if not the falling parachutist, so basically if you have different masses, and if you are expected to talk about which one travels faster, right? So always think about it like this, that if you think about the process of reaching terminal velocity as a story, it's always going to make sense to you. You guys hear my voice clearly? Oh, this is supposed to be on. Yes. Yeah, so for different masses, if you're thinking about it. So for different masses, the idea is that if there is a heavier mass, air resistance would have to increase more to equal that greater weight. So basically, it has more time to accelerate, which is why it can reach a higher speed, right? So do remember this. So this is something that I thought was worth discussing. So the process of reaching terminal velocity. In recent times, there have been a lot of questions on drag force as well. So basically, previously it always used to be just the velocity. It just used to be air resistance. Now it's also a lot in the context of drag forces. The objects are moving through liquid, right? So yeah, that's nothing too fancy really. And relative speed of approach and relative speed of separation. So this thing, that is important. Also expect a difficult question on turning effects. It wasn't asked all that much as it was supposed to really in your paper, because usually you have a full-blown question where you also need to use both the conditions for equilibrium, where the resultant force is zero, the resultant moment is zero. That was not asked in this paper. So turning effects, conditions of equilibrium. And you could also have a vector triangle in this case. There was this one question. I'm just going to show you this. Later, you can go through the YouTube video to find out its reasoning. This was, in my mind, the most difficult question of this March 24 paper. which was this one. You guys might remember seeing this. And in this one, you did need some knowledge of how the trigonometric ratios sine cos work. So in this, no values at all were given to you, just a diagram, and you were supposed to list which of the forces were there in the order of increasing magnitude, right? So in this case, I wrote out the equations, all the equations that I could possibly think of, and that's what led me to the answer. Also, if you are, for example, provided with a question where you have some forces labeled, and for example, you don't have anything to do with that force really, always remember that unwanted forces you can get rid of by taking the moment about that point. For example, a question arises where I have some forces also marked here, right? So maybe there was like a force here as well. For example, I only want to find a relationship between T and H. And again, that's something that is also going to be trial and error on your part in that question on the spot. Because I know that I don't have anything to do with this, what I could do is just take the moment about this point. Taking moments about this point basically gets rid of these two forces altogether. And then I can happily look at just what's happening between T sine theta and H sine alpha. Right, so do keep that in mind as well. There have been some questions like this in the past. Similarly, when we talk about the basic idea of the principle of moments, make sure that you know that principle of moments means sum of clockwise moments equals sum of anti-clockwise moments for an object in equilibrium, and that point that you are taking the moments about, it could be anywhere. It could even be a point which is not on the object. What do I mean here? If I make a small diagram, there are some forces acting here. Maybe there is a force here. Maybe this is the pivot. Maybe this is another force. Maybe this is another force. Right? These forces are acting. Now you want to find out, maybe this force is given as 3, maybe this is 5, maybe you need to figure out F, and you are given all the distances with the pivot. When you are going to use this idea that since it's an equilibrium, the sum of clockwise moments equals sum of anti-clockwise moments, you are going to take the moments, and mostly it's about this point, right? But theoretically speaking, you could also maybe take moments about this point. This is also fine, right? So there was a MCQ question a while back that just came to mind. And in that question, the idea was that there is a point X in this principle of moments. So it was told that sum of clockwise moments equals sum of anti-clockwise moments for a balanced object about this point X. And then the examiner asked, what is this point X? So some options said the pivot, some said the center of gravity, some said something else. And the correct option said that it could be any point, right? So whatever you take the clockwise moment about, you would also take the anti-clockwise moment about that same point. So just make sure that you understand what this means here. All right, so this is something. Upthrust definitely going to be on there tomorrow. With respect to Newton's second law questions, remember that upthrust is always upwards. Similarly, weight is always downwards, but drag opposes the direction of motion. If something is falling through a liquid, drag would be upwards. If something is rising up, drag would be downwards. But upthrust and weight are irrespective of however the object is moving. Upthrust always upwards, weight always downwards. With questions related to upthrust, do make sure that if some volume is given to you, it only acts on the volume beneath the surface. And on alt, you'll have a full compilation of questions related to upthrust that we did. And it's very hand-picked questions, which are the most difficult ones. No, drag is not the same as upthrust. Drag is just a resistive force. Upthrust is basically the force acting on an object due to its pressure differences. Rania, do go through this. This is very worrying that you're asking this question right now. Do go through the upthrust videos on alt. Drag is not the same as upthrust at all. All right. So upthrust and with upthrust, yeah, so there was that polar bear question. If some of you might remember, that polar bear question was a good one. And then this is upthrust. There will also definitely be a question of density. So it could be density, it could be pressure. Some of you guys might remember this question that you have some volume of a certain density of liquid mix and some volume of another uh, density of liquid mixed together, and you are asked to find the density of that final mixture. So remember that from the volumes and the densities, you find out the masses, and then once you have the masses, you can add them up. That's going to be the total mass. Adding up the volumes, that's going to be the total volume, and then you use rho equals to m over v. So it's both are totals. Similarly, questions related to liquid pressure. So the manometer questions and all that, which we've also done in a lot of detail in class. All right, we'll do one like that. So this is where, again, it's sort of dragging here because this is the unit on forces, density, and pressure. And this actually does conclude way before MCQ number 20, but I'm just doing all the possible questions in my mind, which could come in there. So liquid pressure, density, what else? Again, maybe looking at the syllabus will tell me something. Couples, usually there is a very easy question regarding this, and it's very easy. Just remember this, that couples do not have any resultant force, but they do produce a resultant moment, right? No resultant force, but they do have a resultant moment. So yeah, that's about couples. Definitely a question is going to be on there tomorrow. Couples is one of those questions that the examiner basically gives you a chance to score some good marks with some of these easy questions. Then I guess it's time that we move on to work energy power. So in work energy power, uh, some people also actually requested me to do some questions on work energy. Apologies, I couldn't just get around to doing that. Maybe we'll do some like those today, especially the friction questions. So with energy, again, there is a pretty generic type of question which comes in. Let's have a look at here. This was a different type of question as to what usually comes in. But except this, there's always a question on efficiency. Let's see, let's go on to an older paper here. So you have a question on efficiency. This I remember was a difficult question. So this one said, an escalator is 60 meters long and lifts passengers through a vertical height of 30 meters. Now, in questions related to this, what is going to puzzle you is which distance do we take? And that depends on what forces the examiner gives you. To drive the escalator against the forces of friction when there are no passenger requires a power of 2 kilowatts. So if there is no passenger, just overcoming the force of friction requires this power. The escalator is used by passengers of average mass 60 kg and the power to overcome friction is still the same, 2 kilowatts. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meters per second? All right. So first off, something very basic that we can do is we can find out the total mass of the passengers, which is just going to be 60 times 20. Right, this is the total mass. and then I could just multiply that by 9.81 to get the total weight. Right, so that's 11 point, so 11772 newtons. This is downwards, right? All of this weight is downwards. So yeah, so you still need 2 kilowatts, right? And then it says, so for 20 passengers. So for 20 passengers, we just calculated the weight. So using the formula for potential energy, we can calculate how much potential energy it basically gains. So the formula would usually be mgh. But here I am asked the power. And instead of height, I am given the speed, right? So when it is carrying 20 passengers and is traveling at 0.75 meters per second. So what I can do in this case, if it travels like this in 0.75 meters per second, I can also find the time according to this distance. So I can use 0.75 speed equals distance over time. So from this, I can get the time. So 60 over 0.75, time turns out to be 80 seconds. So from the energy that I would get, which would be 11772 times 30, so 11772 times 30. This is 353,160. This is just the change in potential energy. Dividing this by the time is going to give me the power. And just the power here, dividing by time, this turns out to be 4.4 kilowatts. 4.4 kilowatts of opposing the weight, and then 2 kilowatts of overcoming the friction makes it 6.4 kilowatts overcoming this, right? So in this case, you had to be very precise with what distance you had to use for the GPE and what distance did you have to use for the time calculation. Velocity is up the slope, which is why we use the other one. We are adding the 2 kilowatt because this is always going to be the power required because that's just used to overcome the friction. That's the reason. So there are some of these questions. Usually you might find that power is definitely an easier topic in your syllabus, but sometimes you might have questions like these which are slightly out. This is, by the way, a force on a question on what you requested, Rania. So if it's rising up, drag is downwards, right? And it was rising up at terminal velocity, so forces are definitely balanced. So x equals y plus z. So this or this. It says z is the viscous force, z is weight, y is viscous force, y is weight. So in this case, the idea is obviously it must equal the sum of these. Upthrust is x, which is equal to y plus z. So is y the viscous force or is, just a second, which one is this? Yeah, I just remembered this question now all of a sudden. So in this case, the idea is that this is the upthrust, right? Which we know is rho GV. And there is the weight, which is basically mg, and which we write as, if we want to write it in terms of volume, so it's going to be rho GV as well. But remember that in this case, the rho is of the solid, this rho is of the liquid, right? So this air bubble is rising in water. Now what this means, and there are a couple of ways to do this question. This one is how I like to talk about it. This is a air bubble rising in, what do you call it? Air bubble rising in water. So this is air, right? So this solid that I'm talking about is basically this air bubble, which is air. So definitely U is greater than W. But because this upthrust is really what? Upthrust is equal to the volume, it's basically equal, numerically equal to the weight of water displaced, right? And that is definitely going to be greater than the weight of the bubble. So this means that the weight of the bubble in itself is very, very small, and the larger force is drag. So this question was like extra hard because of this certain idea, right? Because it's an air bubble, and the air bubble idea is that since it's not as dense, so its weight is going to be much smaller, and the larger force is the drag. That's one way to go about it. The other one is to think about what upthrust really means, right? So good grip on upthrust is absolutely essential for tomorrow. Anyway, a lot of time is being spent here. So couples, no, it was not in air. The bubble was air. It was in liquid, right? So because liquid has a much higher density than air, the upthrust would be large, but because of the bubble being made out of air, its own weight would be less, right? Upthrust depends on the density of the fluid that we are in, right? So because it was in water, which is a high density as compared to air, so that's why a lot of upthrust was happening. It doesn't depend on what the material is made of. So later then with couples, and I think this is where we sort of end with this, and then we have work energy. So you'll have questions related to work and maybe direction of forces. So as with the question that we did right now, make sure that you know that if you are, for example, using the work done formula, so force and distance are in the same direction. Definitely you are going to have an efficiency question. In efficiency questions, write out everything very, very clearly. Underline what is the input, what is the output, is it power, is it energy, what do you need to convert to what? So do write out everything. That's just going to make your working much easier. It's going to be easy on the eyes for you as well. So work done, forces, efficiency, and something related to this equation as well. Remember that I write it like this, P equals to FD times V, just to show you that it's the drag force. Also, something else related to this question, related to this idea, is the idea of the slope. So always remember that if something is placed on the slope with this being theta, so this one is the W cos theta component perpendicular to the slope. This one is W sine theta. If you do remember this, things just become a lot more easier. You could also choose to derive this on the spot, but if you memorize this, this is much better. Then we have elastic deformation. So basics of elastic deformation. Elastic versus plastic deformation. So easier questions. You will have questions on spring constant calculation if the examiner is particularly forgiving, or you could also have a question on spring configurations, which is springs in series, springs in parallel, that sort of a thing. So make sure you have a good grip on that as well. Something else which is really important, and I do want to talk about that, is the idea of those ratio questions that I've talked about. So ratio questions related to, what do you call it? Ratio questions related to the Young modulus formula, right? So for example, in that case, you'll be given something like this, that you know this, that this is the formula. And then maybe something will be given to you, like something has a Young modulus this much, and then you have another something else which is made from the same material, but this thing Y as compared to X, this has twice the length, twice the diameter. What's going to be its new extension with the same force applied? Because you know that you are asked the new extension, or you will be asked something like the ratio of the extension of X over the extension of Y. So because you need the extension, make that first the subject of the equation. So X would be FL over AE. Because F is not changing, if the question says you're applying the same force, then what you do is, so let me take this to the next page. So once you figured that out, now what you do is, because force is not changing, you can basically get rid of that. And then you write out the expression. So for xx over xy, so xx is going to be length of x, which is, let's say it was some original length L, area A, and Young modulus E. And by the way, I can also skip Young modulus from the equation if the question says that it's made of the same material. And this material Y is made of twice the length and twice the diameter, but this equation says area. So then you also have to remember this thing, that area in itself is proportional to the square of the diameter. So doubling the area, doubling the diameter causes area to become 4 times that value. This is going to become 4a. So then this cancels out, this cancels out. So you have 1 over half really, which makes it 2. So do make sure that you do this very, very sequentially. All right. We've done a lot of questions like these, and I've went through all of these the exact same way. This question is definitely going to be on your paper tomorrow. All right. So the ratio questions, by the way, the ratio questions can also happen with speed and acceleration. It could also happen with elastic deformation with Young modulus. And it could also happen with the electricity, I equals A and B Q, that equation. So it could be there all, it could be in all of those questions. It's basically just because of this. Because area is pi d square by 4. So because pi over 4 is a constant, so it's just proportional to d square. All right. That's the reason. All right. So ratio questions, this is done. Then questions related to graphs could also be on there. And basically hysteresis loss, if you guys remember. Cases where there is net work done. So do remember that by definition, the area under the fx graph is work done. So area under the fx graph, by the way, is the work done, right? And also remember that sometimes the examiner will mess with you by switching off the graph axes. So remember, it's the area bounded with the extension axis. So even if the graph looks like this is x, this is f, and it bending like this, remember that this is what you're going for. The one that's bounded with the extension axis. All right. So yeah, that is something that comes to mind. So basically, when you load a curve, you are doing work on it. And when you remove that load, that energy is basically restored, right? You get that work back. And when those work done and that energy that you regain, it's not equal, this means some net work was done permanently deforming the spring, or whatever material you have for that matter. So after deformation, then comes waves. So in waves, you have a lot of different questions. there are a lot of questions which have been there, and by the way, they are very definitely mentally stimulating to say the least. Waves questions related to graphs. We have done a few of these in the past. For example, you have a transverse wave, you are given some particles, you are asked which one moves up, which one moves down. Similarly, you have a longitudinal counterpart of that question where you have a wave which is labeled, and then you are asked which particles moves left, which particle moves right. Or another question is which one is a compression, which one is a rarefaction. So that sort of a thing is asked a lot. Let's see if I can find that question that is there in my mind right now. An example question, by the way, is something like this. No, this is not waves. Maybe it's here. So this is one sort of a question, right? How this particle would move when this wave hits it. This is definitely something you need to be very technical about. This is the question that I'm talking about, that there's this particle X and the wave travels from left to right. So how would the displacement time graph look? So we made this conclusion that right after some time, this particle would be moving down to be on this new wave. So it has to have a displacement which decreases, and it's initially at 0. So it must decrease from 0, which is why it was B. Right, and similarly, there was another question related to longitudinal waves as well. No, it's not this one. Yes. This question, this was related to longitudinal waves. You were asked where the rarefaction, where basically the air pressure is going to be lowest, which means where there is a rarefaction. So there was this wave which was going left to right across the room, but this is a sound wave, so this is longitudinal. So when it's going left to right, this means that this particle right now, this is so this is a displacement distance graph. So this particle is at max displacement. So this is furthest right from its position. This particle is at the mean position. This is furthest left. So you can see all of these particles are basically isolating D out, which is why this was a rarefaction. So all of these are great questions, right? So do make sure that these things which are seemingly simple, you do have a good grip on those. All right. So waves, graphs questions, and then basic V equals to F lambda questions, something of that sort. You might have questions on the EM spectrum. In the EM spectrum, do remember that there are some values, some frequency, their order of magnitudes, which you are supposed to know. How I teach it is I remember the wavelengths. For example, whenever I see the order of magnitude given, and by order of magnitude for the layman, if you have a number which is written in standard form, so something points something into 10 to this into 10 to the power something. So that 10 to the power is what I'm calling the order of magnitude. If I see 10 to the negative 7 meters, this automatically means this is the speed of light that I'm talking about. So this means that this is light, right? For example, then if I see any order of magnitude, which is like 10 to the 2 meters, this means this is the longest one, this is radial. I memorize it in terms of wavelength, right? So that is something which is also really important. Without fail, there's always a question on this in the MCQs. And then what else is there? So with waves, how can we forget the infamous question which everybody loses marks on? But you guys shouldn't, because you guys studied it from me. And we did all of these questions, all of the different types of questions of how these could be assessed. We did the question which came in terms of a graph. We've done the questions which correspond to a CRO. There was also a question in the March 24 paper, which also had to do with areas and power and intensity and amplitude, all of that. So, and with a quick side, do go through all the intensity questions which have ever come up, right? This is also definitely going to be on there. It's without fail there on every paper. Polarization, definitely going to be on the paper tomorrow. Polarization, remember that I predicted that it would be there on the P2. It wasn't there on the P2, which means it is going to be there tomorrow, right? With polarization, Malice's law, always remember that in this equation, this theta is the angle between the incoming intensity and the transmission axis. Right? So polarization is going to be on there. Maybe if you're lucky, it's going to be a simple sort of a question like identify which type of wave is not cannot be polarized, and the answer would be a longitudinal wave like sound, which is definitely going to be really nice for you. But otherwise, we would have to then figure out the angles and then do all of that math. No, we don't add the angle. Rani, just go through the practice questions once. It's the angle between the intensity which comes in and the transmission axis. It's also, I guess, there on one of the papers that has been uploaded to YouTube as well. I don't remember which one, but it was there in one of those papers. I don't think it was there in March 24. So it's definitely one of those alt videos then. I can't find it right now. So yeah, polarization. Also something else, which is the diffraction. Just the simple concept of diffraction, when does the most diffraction occur given some gap width, given some wavelength. So remember that the most diffraction occurs when the gap width is approximately equal to the wavelength, right? And also remember those cases that where you have to show decreased diffraction, how the wavefronts look like. So do remember that if this is your gap and these wavefronts are coming in. So let's say this one shows the most diffraction. Do make sure that, for example, if you are given options for wavefronts and you have to select the correct one, the wavelength should not change. It should be the same. But let's say that the examiner plays around with this and then he changes the gap width and then increases it. Again, obviously this is an MCQ paper, so you won't be asked to draw it, but you would be asked to select the correct option. Remember that the part of the wavefronts which basically doesn't even feel the presence of a gap is this one. So this one just passes straight through. And then you just curve the hell out of the rest of the wavefront. This is how the wavefront is going to be. If you make it like this, and this is going to be a common frequent incorrect option, like this, and then it's bended like this. This is wrong, right? The straight part is of an equal length in all of the wavefronts. So do make sure that you see this as well. And then after diffraction, we've done this. So yeah, I think in just waves, it's all this. Doppler effect. do go through the video as well, in which I explain not only how you use the Doppler effect formula, because you guys obviously know that, which is that if it's moving towards, we use the minus sign. If it's moving away, we use the plus sign. But I also showed you guys that if something is increasing in speed or decreasing in speed, then how do you find out how the frequency is, right? So that's super important. So then with waves, probably diffraction grating is not going to be there at all. With superposition, just the principle of superposition might be asked. Remember that the only requirement for superposition is the type of the wave. There are no other requirements. It should just be the same type of wave. So if one is sound, the other one is also sound. If one is light, the other one is also light. Same amplitude, same phase difference, all of this is not a requirement. Same phase difference is a requirement for coherence, which is needed for interference patterns, right? So coherence needs interference. Interference needs coherence. And opposite movement is needed by stationary waves. So waves, same waves of exactly identical waves, same speed, same wavelengths, and same amplitude, everything. So opposite speeds, basically I meant to say opposite directions. So this is needed by stationary waves. Right, so yeah, so that's what this is. Stationary waves is definitely going to be on there. It might also be a question as to the formation and the graphical representation of a stationary wave, so how it moves. Right, it could also have to do with phase difference of stationary waves. So remember that all points between two nodes are in phase, and points between like adjacent nodes, they're out of phase, what I like to call loops. So node, 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 all of these are in phase, all of these, but all of these are out of phase with the adjacent loop, right? So that's what I'm talking about. Apart from this, stationary waves, there's also going to be the double slit. Again, it's totally your luck. Maybe you get a very easy double slit numerical, which you can just get through with. Or you might be asked a more technical question, which basically has to do with how would the fringe width change if something changes, right? And again, just have a quick overview of some of the older past paper questions so that you know exactly what was required in those. So double slit calculation is my bet for now. Path difference, phase difference. Because path difference questions have not come in for quite some time. I think it was there on the March 24 paper. So I'm expecting a phase difference question. And phase difference in terms of that integer multiples and non-integer multiples. So basically integer multiples and odd multiples of half, odd multiples of half. So that's what I'm talking about, right? So for example, at the constructive interferences, you have a phase difference of 0, 360, 720. Whereas for destructive interference, it's exactly 180 degrees. And just to confuse you, the examiner might give you a value which is increased by 360. It's the same thing. So 180 plus 360, which would be 540. Or 360 added to that as well, right? So yeah, that's just some ideas from me. Superposition and superposition, those wavelength calculations in which you have open, closed tubes or strings. You're asked to find the wave speed, the wavelength, so that sort of thing. Then next, so now all of waves is wrapped up. am I forgetting something? No, stationary waves, yes. And yeah, diffraction grating is definitely going to be not assessed all that much if it is going to be assessed at all. So then with electricity, you always have a question without fault, which is related to the quantization of charge, where you would be asked whether this charge can actually exist or not. And the idea is that it must be an integer multiple of the charge of an electron, which is 1.60 into 10 to the negative 19. So it must be an integer multiple of that. Then again, with I equals to A and VQ, you might have a ratio question. You could also have that coupled together with this. And there have been examples of these in the past, which were really tricky questions. So ratio questions. Also, if you are given a question on a conductor, which is somehow stretched or length changes, or, and this would be given to you that length changes, and you might be told that the volume is unchanged. So if this is said, that if volume is unchanged, at this very point, you must then start thinking about this equation. That volume equals area times the cross-sectional area times the length. So if the length is going up, this means that the cross-sectional area would be going down. And then you would use ratios to find what that is. So don't sleep on this, right? The statement is very, very important. And this will determine whether you find the right answer or not. So then after this, you will have questions either of the IV characteristic of a filament lamp or a diode. With a filament lamp or a diode, do make sure, and I've talked about this once or twice in class as well, that just being a straight line does not mean obeying Ohm's law. It should be a straight line through origin. So Ohm's law is only when you have a straight line through origin. So as you can see that with the diode, after some potential difference is applied, it then becomes a straight line. But in that case, it's not obeying Ohm's law, right? And basically Ohm's law means the resistance becomes constant. So also remember this, that a straight line does not mean resistance becomes constant, because resistance is not the rate of change of voltage with respect to gradient, it's just V over R. So that must be constant, and that by the math, how it works out, it only happens when you have a straight line going through the origin, right? So just have a go through the last couple of papers that I've done, and you will exactly understand what I'm talking about. Then also make sure that you know your circuit symbols, what a microphone looks like, what a buzzer looks like, what a relay looks like. Maybe something like that could come up. Coherence basically means constant phase difference. This is the requirement for interference. If you don't have coherence, you will not see an interference pattern. So it means that the phase difference is not changing, right? So phase difference, if you know what phase difference is, so this means that one wave and another wave, one should not be racing ahead of another. So if one is like this and the other one is like this is fine. Because as you can see, if these peaks are this far apart, this is approximately the same distance. This is constant phase difference. Must always have the same phase difference. One must not be racing ahead, the other one must not be falling behind. All right, then a potential divider. Was a potential divider asked? Let's see. No, it was potential divider was not asked. So using an LDR, a thermistor. So that sort of a question can definitely come in. Internal resistance, I also expect that to be assessed in one way or another. With internal resistance, make sure that you understand this, you remember this equation for the terminal potential difference in terms of the graph as well. And then, let's see. So really basic questions related to KCL, KVL are what I'm expecting. Like this is the conservation of what, this is the conservation of what do the laws really say? That sort of a question is what I think can come in. And then the combination of resistors. So series parallel, remember that in series resistances, the total series resistance is larger than the largest resistor. In parallel, it's the opposite, it's smaller than the smallest resistor. So yeah, that's in electricity, it's a bit more difficult to predict. Maybe, just maybe, differences between EMF and potential difference in terms of the energy transfer, and were done either by the charge or by the cell on the charge. That's what's different. And if you are somewhat unlucky, because as a student, I totally hated this thing, which is the potentiometer and null methods. But right now, the idea is that you do have a very, very good video by me, which does talk about exactly what you need for a potentiometer and how that works. So some things that you need to look at with a correct configuration of the potentiometer is that both of the cells must be connected plus plus or minus minus. The galvanometer must be connected with that new cell in that smaller loop, and the new cell that you are trying to figure out the EMF of, that EMF must be less than the driver cell EMF, that known EMF. So the new EMF which comes in should be smaller. And then we already know how to find out the balance point, that balance length. Something else which is covered in the video, by the way, is that the internal resistance of the new cell will not affect the balance point, but the internal resistance of the driver cell would affect the balance point. Right? All of this is covered in the few videos that I've done, and they are also up there on YouTube. So yeah, so that's that, and that's really the crux of this chapter. So for some reason, we got done in less than the amount of videos for O levels, the amount of questions that I predicted for O levels, but it's kind of makes sense because O level syllabus is slightly a bit more. So particle physics, alpha scattering, definitely going to be assessed, definitely going to be tested in terms of the observations and outcomes. What observation leads to what outcome? Uh, 55. For you to score marks, isotopes or some sort of question on nuclide notation, where you just simply have to calculate the number of neutrons. And 56. So for alpha, beta, gamma, you guys might remember that in O levels, you needed to remember some things about that. You don't really need to remember it here. Something here that you do need to remember in alpha, beta, gamma is obviously the equations and what type of particle is emitted. But for alpha, beta, what I'm predicting, I have a really strong feeling this is going to be tested tomorrow, is in alpha, beta, the difference in kinetic energies. So remember that in alpha, the alpha nuclei have a discrete kinetic energy. It's either this or this. Whereas for beta, it's a continuous range of energies. And the reason is that with beta negative, an anti-neutrino is emitted. With beta positive, a neutrino is emitted. And that also takes up a varying share of the energy. And that basically gives the remainder is basically the energy of the beta particle. So that's varying. So that is something. Also make sure you know how to work with small u, the atomic mass unit. It's not really a separate question, by the way. But for example, if I'm talking about a alpha nucleus, an alpha particle, which is the helium nucleus, so the mass is 4u. So you should know how to do this, balancing equations and whatnot. So conservation of proton number, nucleon number. Then the changes in the nucleus during beta decay. Again, a question which is asked almost every other session, that does a neutron convert to a proton? Does a proton convert to a neutron? In my opinion, this is going to be asked because it was not asked here, right? And mesons and baryons were asked, so that's probably not going to be asked. Again, that's just my opinion. So quark flavors and charges. Basically, the idea of antiparticles could be sort of used in this last question, where you have to basically make a charge, where you have to make a particle that contains these particles that contain these quarks. So you know that UCT is positive 2 by 3 and the rest are negative 1 by 3, and then you can make antiparticles very easily. Right, so that's something from my side. Apart from this, some tips, like the tips that I gave at the start were much more general, but some other tips would probably be this, that always pay attention to words that are underlined in your paper. For example, must means something that is always true. For example, that some of you guys might know this, that the limit of proportionality and the elastic limit for actual practical materials are very, very close. But again, if you're talking about must, so if a question talks about what must be true, so that is a statement which is universally true for all materials. So for example, for a certain metal wire, it's true that the limit of proportionality is also the elastic limit for a particular type of material. Could be true that just as force and extension are no longer proportional, it also then loses its shape. But a much more universal statement would be that the limit of proportionality is only the point where force and extension are no longer proportional. Similarly, you might also see this word same scales. So with same scales, do make sure that you understand that the magnitude of each and every number on there is the same. When I hear the word same scales, this example comes to mind, where there was basically, and some of you guys might remember this question, that there was this question of something which was falling in vacuum at first, and the graph was like this. And then you were asked to find what is going to be the graph on the same scales of this object now falling in air. So if it's falling in air, this means that it's definitely going to experience air resistance. And by the way, that's another keyword. So falling in air means it's going to experience air resistance. And there were these two types of graphs. Which one is going to be correct here? And by the way, I'm sorry, this is a speed time graph, and this is also speed time graphs. Which one is correct? No, this one is correct. And the reason being this, that basically the gradient of a speed time graph is acceleration. If it says the same scale, so it means that the same one initially should show the same gradient. You know that if I draw a tangent to that initial point, initially it falls with acceleration due to gravity. That's not happening here, but it sort of seems to happen here, right? So that's why the answer to this one was graph 2. So same scales falling in air. Similarly, if somebody tells you that something falls from a long height means that it has fallen long enough for it to actually reach terminal velocity, right? So if I do this, long height, this means terminal velocity is reached. All right, so yeah, that's just some things that come to mind. And these are like some keywords. Some people ask for keywords, so that's, yes. All right, guys. So it's been pretty long, but again, anything to help you guys ace your exams. So yeah, as soon as this finishes processing, which will be probably around 11 p.m., I'll try to upload this, and I'll also try to upload the PDFs, right? The PDF of the questions that we've done. So that's then also with you. If you guys just don't want to go through the entire video, you just want to go through the PDF and see the questions, you can do that as well. All right, guys, best of luck. Don't really stress over it. And yeah, if you want to do it the entire year, then honestly, you won't be able to do it in one night either. That's just them facts. So yeah, just sleep well and eat well before going into the exam and just do your best. In MCQ, sleep is more important than in any other paper because it's really tricky. All right, take care. Let me know if you guys need any more help. I'll be online on WhatsApp till about 12. All right. Take care, guys. Allah Hafiz.